Hi, Net 1 aspirants. It's Math with AUB. Today, our question from the KIPS manual based on complex number. Part number 1, complex number. Complex number. Let me write for you complex numbers. Complex numbers. For complex numbers, you must be familiar from what do you mean by additive inverse, multiplicative inverse, what do you mean by conjugate of a complex number, what do you mean by conjugate of a complex number, what is De Moivre's theorem, how to apply this, and how to find argument means angle of a complex number. Same like polar coordinates theta is equal to tan inverse of y upon x. Without wasting time, let's jot down to question number 1. Modulus of 1 minus cos theta and iota sin theta. Let me write the question. 1 minus cos theta plus iota sin theta. Let me change the marker. Modulus is given by root, a real part, that's our 1 minus cos theta square, and coefficient of imaginary part. Coefficient of imaginary part, without taking iota, it's r sine. Modulus is defined by a real part square, coefficient of imaginary part is square. Just jot down the business. Perfect square quantity, it is 1 square minus 2 times 1 times cos theta plus cos squared theta, and here it is sine squared theta. You are familiar, cos square sine square, it is equal to 1, it will become 1 minus 2 times cos theta plus 1. 1 and 1, it will become 2 minus 2 cos theta. Taking 2 common in the root, we have 1 minus cos theta. You are familiar from the half angle, 1 minus cos theta is given by 2 times sine square theta over 2. Formula for 1 minus cos. If it would have been 1 plus cos, I would have written here cos. The background formulas are this: sine square theta is equal to 1 minus cos 2 theta upon 2. This formula props up from here, shifting to here and halving the angle, and similarly cos square theta is given by 1 plus cos 2 theta over 2. Applying this identity, we have arrived here. Now it's a perfect square quantity. The square root of 2 into 2, 2 sine theta over 2. That's our answer in that case. Question number 2, we have given if z is equal to cos pi over 4 plus iota sine pi over 6, then argument of z, then argument of z. Don't bother yourself. There is pi upon 4, there is pi upon 6. They are not same. If they would have been similar, then we have easily merged them. What is the value of cos pi upon 4? Write down 1 over square root 2 plus sine pi upon 6, 1 8 30. I think it is 1 over 2. Now we are in a position to find angle that's given by tan inverse of or arc tan y over x. That's our x, that's our y. We are familiar from rectangular to polar coordinates. Theta is tan inverse of 1 over 2 divided by 1 over root 2. I am facilitating my work. Instead of upon, I have introduced deviation. It will become theta is equal tan inverse of 1 over 2 times under root 2 over 1. Rationalize or apply direct table. It's up to you. We have 1 over root 2. 1 over root 2. For such type of questions, take a tip. A under root A, it's root A. Under root A over A, it's equal to 1 over under root A. Apply tiny exponent rule, 1 minus 1 upon 2, you will get A raised 1 over 2. Or A raised 1 over 2, and here is A 1 minus 1 upon 2, you will get a root A in the denominator, or one can rationalize. I have utilized this fact, I have utilized this, there is root, there is no root. Applying table 1 minus 1 upon 2, I will get under root 2. So my right option in that case is C. My right option is C. Without wasting time, moving towards question number 3, that is, if z is equal to 1 plus iota, if z is equal to 1 plus iota, if z is equal to 1 plus iota, then iota z lies in which quadrant? Z is given by 1 plus iota. Cool. We are asked to find 1 plus iota z lies in which quadrant? 1 plus iota. Tiny calculation, it will become iota. It will become iota square. We are familiar, value of iota square is minus 1. So it will become iota minus 1, or let me write minus 1 plus iota. Mine x is negative 1, mine y is 1. We are familiar, x is negative and y is positive. X negative, y positive, x negative, y positive. It will lie in second quadrant. This is our first quadrant, that's our second quadrant, third quadrant, fourth quadrant. Start measuring angle from positive x-axis in entire clockwise direction, or counterclockwise direction. X negative, y positive means it is our second quadrant. It is our second quadrant. Moving towards next question, the principal value of the argument is this or that or whatever the case is. We have that is equal to minus 1 minus iota. Theta is equal to tan inverse of minus 1 divided by minus 1. Here it seems to be minus 1, but both x and y, they are negative. It lies in the third quadrant. Let me, mine x is 1, mine y is 1. We have such type of its magnitude or its representation. If we start from here, then we stuck to this according to polar coordinates. From pole to this required OP, that is 90 plus 45. 90 plus 45, it will become 135. They are in clockwise direction. From here, anti-clockwise direction, here clockwise direction. It is negative 135. Negative 135 can be represented as negative 3 pi upon 4 by multiplying pi over 180. That is our answer in that case. And don't forget, our principal angle must lie from minus pi to pi. That is, semi-closed interval is the value of this principal argument. From minus pi to positive pi. Keeping this fact in mind, or minus 135, how we are measuring nearest angle from according to polar coordinates from this to our required OP. We are measuring in clockwise direction. That's why it's negative. Minus 135, there is no option. But if we convert y negative 135 into radian, it's tantamount to negative 3 pi upon 4. So our option in that case is C. Or have a look at this. It is in third quadrant. It is the nearest way to measure the angle from polar coordinates. Or one can write minus pi, and whatever the angle here, it is pi upon 4. If we direct its value of pi upon 4 here, quadrantal angles minus pi to pi upon 4, simplify this concept, minus 4 pi plus pi, it will also give you minus 3 pi upon 4. But graphical, it's good one, it's the nearest one, it's the simpler one. 90 plus 45, it will become 135, but we are measuring in anti-clockwise direction. Negative 135. Convert this one into positive, it will become minus 3 pi upon 4. Such type of concepts are simple to apply and understand as well as comprehend. Moving towards question number next, a good question, a googly type question, but simple one. Let's see the depth of these complex numbers. We have sine theta plus iota cos theta over all 4. Sine theta plus iota cos theta over all power 4. Don't jump to conclusion. You are not in a position to apply de Moivre's theorem. it states that cos theta plus iota sin theta raised m. Then we can multiply the angle in the argument. Sorry, we can multiply the power in argument. We can multiply the power in argument. Iota sine m theta. Look at this. This is not the case. Here, iota with sine. In reality, here it is with cos. Manipulate iota here. Manipulate iota here. It's a wonderful concept. Take iota common. Take iota common. How to take iota common? Look at this. Iota common. Iota common means dividing by iota. Iota common means dividing by iota. I can write 1 upon iota sin theta plus iota upon iota cos theta overall power 4. I have taken iota common. Iota common means divide, multiply and divide by iota. Divide, multiply and divide by iota. Iota has been utilized here. This power can be given to iota. Iota power 4 here 1 upon iota sin theta plus cos theta. Cool. Iota 4 is equal to 1. It is no more. And we are familiar 1 upon iota. 1 upon iota is equal to minus iota. 1 upon iota is equal to minus iota. Let me write these for you. You are familiar, iota square is equal to minus 1, no need to tell you. Iota cube minus iota, iota 4 is equal to 1. Don't forget about this word. 1 upon iota is equal to minus iota. Minus 1 upon iota is equal to positive iota. They will facilitate your calculation. Keep these things in mind. These things in mind. Okay. Power 4. Question is taking shape. I can write cos theta, negative iota sin theta, power 4 or power 4. If middle symbol is positive, then we are in a position to apply de Moivre's theorem. If there is a positive sign, we can apply de Moivre's theorem. Utilizing the fact of even and odd functions, cos is even function. If I write theta or minus theta, it's cool. Cos negative times theta is equal to cos theta, because cos is an even function, minus automatically vanishes, plus iota sine. Minus sine theta can be written as sine argument negative sine negative theta. Sine negative theta overall power 4. Here minus automatically vanishes. Cos is an even function. Cos is an even function. And here minus comes here. Sine is an odd function. Minus remains intact. So this position, this situation, we have transformed in a gentle manner to the situation cos theta plus iota sin theta. Cos theta plus iota sin theta. In order, now we are in a position to apply this. Now we are in a position to apply de Moivre's theorem, which says that cos theta plus iota sin theta raised m can be written as cos m theta plus iota sin m theta. Here value of m is 4, so I can write cos negative 4 theta plus iota sine negative 4 theta. One can write here, or its abbreviation or short form, cis negative 4 theta. Cis negative 4 theta. That's our answer in that case. That's our answer in that case. What about, look at the options. So this is our right option, D. D. Minus has been neutralized. Minus will be neutralized, and this minus will come into play. It can be written as cos 4 theta minus iota sine 4 theta. Until unless we have this shape cos theta plus iota sin theta, we are not in a position to apply de Moivre's theorem. We are not in a position to apply de Moivre's theorem. It is a simple identity. One is familiar. E power iota theta, it's equal to cos theta plus iota sin theta. Euler identity. Euler. We pronounce Euler, write Euler. We write Euler but pronounce Euler. Euler. Moving towards next question, it is said that if z is root 5 comma root 3, find the modulus of its inverse. Find the modulus of its inverse. Let's see and find out how to deal with this. We have question number 6, I think. Yes, cos z is equal to root 5 comma root 3. Then we are asked to find z inverse modulus. Z inverse modulus. Its z inverse is given by definition a comma b. Its multiplicative inverse is given by a over a square plus b square minus b over a square plus b square. That's multiplicative inverse of a complex number. Here, this is value of A, this is value of B. Utilize, we have root 5 square plus root 3 square negative root 3 root 5 square root 3 square. It will become root 5 divided by 8. Square root of 5 is 5. Square of 5 square root 5 square under root no more square under root no more 5 plus 3 8. And here minus root 3 divided by 8 as well. Now this is the multiplicative inverse of our given complex number. This is the multiplicative inverse. We are asked to find its modulus magnitude that's given by real part square plus coefficient of negative part square. It will become only 5 divided by 64, 3 divided by 64. Denominator is homogeneous, write 64 one times. 5 plus 3, 5 plus 3, I am not in the frame. Okay, I am writing it again. Okay, be in frame. Find its modulus is given by the square of this one. Under root 5 over 8 whole square negative under root 3 over 8 whole square. It will be something 5 over 64 plus 3 over 64. Denominators are homogeneous. Write one time, no transition in the numerators. 5 plus 3. 5 plus 3. 5 plus 3. Now it will become 8 over 64. Applying table, we have 1 root 8. The square root of 1 is 1. 8 can be written as 2 times 2 times 2. Pair of 2 and inside 2. That is the magnitude of this z bar 1 upon 2 under root 2, 1 upon 2 under root 2. So C is the right option in that case. Moving towards question number 7. What it states? Yes, we have given z3 minus a if means the given part. I would have written questions here to facilitate my work. I am feeling some difficulty writing here. If z is, next time, z is 3 minus a and z inverse is given to us, that is 3 over 13 plus 2 over 13. What is value of it? The conjugate of this one is given by 3 over 3 square plus minus a square, and here minus a 3 square plus negative root square. So we have 3 over 9 plus a square, and here a over 9 plus a square. Now comparing the situation, our a is equal to 2. Number 1, or we can compare from denominator to denominator. 9 plus a square is equal to 30. A square is equal to 13 minus 9. A square is equal to 4. So a is equal to plus minus 2. A is equal to plus minus 2. We have to select. Here it is already minus. For multiplicative inverse, minus will become plus. So a is to the right option. A is equal to the right option. Or simply you can compare. Apply inverse formula, a over a square plus b square minus a over 9 plus a square. From this one can infer that value of a is minus 2. Value of a is minus 2 because we put here minus 2. A value of a is 2. And here it is 2. Minus a minus 2, it will become positive 2 as it is required. So value of a is 2 in that case. Or simply compare. Here we have minus a, according to definition of inverse, minus a over minus times minus a, it will become plus a. Here comes 2. So value of A is 2. Value of A is 2 in that case. Where it is? Value of A is 2 or minus 2 in that case. Here it is minus, value of A is 2. What I have, value of A is 2. If I would have written minus 2, here it will become positive 2. So value of A is only 2. Value of A is only 2. If I write here, look at this, 3 minus 2. It can be written as 3 over square of 3 is 9 plus 4 minus changing symbol 2 over 9 plus 4. It is telling the fact that value of A is 2. Value of A is 2. Value of A is 2. From this one can infer that value of A is 2, or one can compare here. It is positive, negative, but reconcile the fact that multiplicative inverse is given by A comma B raised minus 1 is given by A square over A square plus B square minus B over A square plus B square. So we have to change the symbol. We have to change the symbol. That's why we have taken the positive 2. Our answer in that case, positive 2, positive 2. Or let me give some more light on that. Here, it's our A, 3 minus A. It can be written as for multiplicative no 3 minus A iota. Rationalize 3 plus A iota divided by 3 plus A iota. 3 plus A iota divided by 9 minus A square iota square. It will become 3 plus A iota divided by 9 plus A square, as value of iota square is minus 1. It is given to us, it's equal to 3 comma 2, 3 comma 2 over 13. 3 over 13, 2 over 13. Now compare. It can be written as 3, 9 plus A square, A over 9 plus A square is equal to 3 over 13 comma 2 over 13. Now compare. Value of A is 2. Value of A is 2. The simple method. You can plug in direct by the definition of complex number, by the definition of inverse. A is equal to A square plus B square minus B over A square plus B square. So we have to change the symbol, or one can compare from this. A is equal to 2. A is equal to. If we compare the denominators, we are going to have A is equal to plus minus 2. Plus minus 2. We have to narrow down ourselves. Positive, the negative. Positive or negative. Positive or negative. From this, one can compare A. Value of A is 2. Value of A is 2 in that case. A simple but tricky question. We have sorted out. The final question today. 5 to 7 questions are more coming for you. Selection from the Kipps manual present. Question number 8, the last one. Cos theta plus iota sin theta raised 8 divided by cos 4 theta minus iota sin 4 theta. Here it is 6. Okay, cool. I have written 8. 6. Okay, let's see another magic. Cos theta plus iota sin theta from Euler, it's raised to e iota theta. It is equal to e iota theta. So instead of cos theta plus iota sin theta, I can write e iota theta raised 6. Making the platform for this one, cos negative 4 theta plus iota sin negative 4 theta. Look at this. Now I am in a position to apply same identity Euler. It will become e raised 6 iota theta over, it's equal to e raised negative 4 iota theta. It's out of the box solution. It is tantamount to applying de Moivre's theorem. It's tantamount to applying de Moivre's theorem. You can grapple the situation. Now, basis of some subject lower power from upper, we have 6 iota theta minus 4 iota theta. It will become e raised 6 iota theta plus 4 iota theta, means e power 10 iota theta. 10 iota theta can be written as cos 10 theta plus iota sine 10 theta, or one can write CIS tan theta, CIS tan theta. This is all the juggling ways of applying De Moivre's theorem. It is the famous identity from Euler. From this, you can easily comprehend your De Morgan law, why you are multiplying the power with the angle when we have the situation cos theta plus iota sin theta. If you write cos theta plus iota sin theta is equal to e power iota theta, then it will become natural for you just to deal with the exponents of e. Just deal the exponents of e naturally and utilize this identity to get in. It is your entrance, it is your exit. It is your entrance, it is your exit. It's my tiny effort for net preparation on complex number. Second part of the remaining good questions from complex number are remaining for you. They are upcoming for you. It's all by itself. Next.